I just drank a cup of water. Can I reverse this? Can I undrink this water? Well, no. If I fry some eggs, can I unfry those eggs? Or I cook a steak, can I uncook that steak? Well, no. So you agree with me that some processes can be reversed and some cannot be reversed. What if I put on my socks and then I put on my shoes? Can I reverse that process? Well, yes. Just take off your shoes and then take off your socks. So here's the graph of 2x plus 2. And these are 4 coordinates on that graph. The numbers on the left are the x coordinates, and the numbers on the right are the y coordinates. Now, those 4 points, how did we get those 4 points? So what we do is we take an x value, we put it into this equation, and that answer is the y value. Let's do that and see. Pretty simple, right? Now this is going to give us those coordinates from earlier. This numbers here, those are our x, and these numbers here, those are our y values. So let's write them as coordinates. And then we have it. Now, you pretty much, you know this, you know how to do all this stuff. Here's something I want you to notice, okay? Let's take all of these numbers and swap them with these numbers here. So the y values are going to take the place of the x values, and the x values are going to take the place of the y values. We're swapping them around. Let's see what's going to do to the graph. So what used to be y is now x, and what used to be x is now y. Now, what did you see? It seems like that original blue graph fell a little bit. It tilted to the side, but it didn't actually move. I didn't move it, actually. All right? We actually didn't even touch it. We created a new graph. Yeah, we created a new graph. I just haven't showed you yet. Let me show you now. We are reflecting this blue graph over the line y equals x. Now that's what inverse functions are about. Inverse functions mirror the original function over that line you saw, y equals x. Every inverse function does the same thing. Now, how do we know which functions have inverses? Because not every function has an inverse. Only functions that are one-to-one have an inverse. We spoke about one-to-one functions, what they are, how to find them in this video over here. But just to give you a quick recap, if I draw a horizontal line on that graph and it touches that graph at more than one place, it's not a one-to-one function. But if it doesn't, it is a one-to-one function. Don't worry. All right, I'll show you how it works in this video. So now we've seen that some graphs, they pass the horizontal line test, and some of them, they fail the horizontal line test. So now I've got a question for you. Is it possible that there's a graph that fails the horizontal line test, but somehow we can get an inverse function for it? Well, yes. Surprisingly, yes. This is how we do it. So here's a parabola, okay? If I draw a horizontal line, it fails because it touches the graph at more than one place. You see, it keeps failing. But if I tell you that we take out this left side, we restrict it so that we only look at where x is greater than or equal to 0. So it's equal to 0 or greater than. Now, this piece alone is a one-to-one function because any horizontal line I draw only touches now the graph at one place. So now there's something interesting that happens. If I only take this part and I reflect it over the line, y equals x, this is what you're going to see. Now, there's two things I want you to notice from what we just did. We looked at the whole function and we said, This doesn't work. We cut it off. We throw it away because as a whole, it breaks the horizontal line test. As a whole, it's not a one-to-one function. But if you cut off that piece, get out of here. We don't want you. And we look at the specific piece. Now it becomes a one-to-one function. That's the first thing I want you to notice. That's called restricting the domain. The second thing I want you to notice is that I never gave you any equation. I never gave you the equation for that parabola. Yeah, you may know that a parabola is x squared something, all right? But I never gave you the equation. Now come closer because there's something I want to whisper in your ear. You can get the inverse function, the graph of the inverse function, by reflecting the original over the line y equals x. Okay. We've done enough graphs now, reflecting, chopping off and all that stuff, right? Now, let's focus on the inverse function. How do you get the equation now? If I give you an equation of a function, how do you get the inverse from that equation? No graphs now. So here's our function. What's the first step? Change this f of x into a y. Remember what this represents? This f of x represents the y. All right, so change this f of x into a y. To work with it simpler. The second step is to change every y into an x and every x into a y. And now we solve for y. And that's our inverse function. That's our inverse function. But don't leave it like this, all right? This is not the right notation to use. This is the final notation. Change this y into this. And there's our inverse function. That's, you only need those three steps. Those three steps, change this f of x into a y, and then change every y into an x, and every x into a y. That's what we did here, all right? And then just solve for y. And then after you solve for y, just change that y into the right notation, which is this. F inverse of x is equal to x plus 5. So there's another example. Let's just follow our rules. The first rule says, change the f of x into a y. Let's do that. The second rule is interchange x and y. So for every x you see, make it a y. For every y you see, make it an x. Let's do that. Now we just solve for y. And that's our inverse function. This is our inverse function. But remember, we don't want it as y is equal to something. We need to use the proper notation. So to rewrite this as proper notation, it would look like this. Now I know I've been running my mouth a lot, but before I teach you this one last important thing about inverse functions, remember what we said? We said that the domain of the original function now becomes the range of the inverse, and the range of the original now becomes the domain of the inverse. Turns out that is not the only thing that swap. If you have a function with a vertical asymptote and a horizontal asymptote, that also swaps. Now here's the graph of g of x. G of x has a vertical asymptote and it has a horizontal asymptote. Now we're going to reflect g of x over the line y equals x. And we're going to get this red graph. And this red graph also has a vertical asymptote and it has a horizontal asymptote. Now notice something. The vertical asymptote of the blue is now the horizontal asymptote of the red. And the horizontal asymptote of the blue is now the vertical asymptote of the red. So believe me when I tell you that the inverse function is really the undo button. So here are two functions, okay? This is the original, this is the inverse. We are saying if I put in a number here, I get the answer, and I take that answer, I put it in here, I must get the original number. I'll show you. So if I put in 3 here, I'm going to get 3 plus 1, right? Which is 4. If I take that 4 and I put it in here, I get 4 minus 1. What's the answer? 3. So I got the same, I landed back where I started. In other words, if I put on a vest, I put on a shirt, I put on a jacket, I put on a beanie, then I put on my glasses, the inverse function will take off my glasses, take off my beanie, take off my jacket, take off my shirt, and take off my vest. No matter how much of work I did, I will land back where I started. Instead of putting in an x, a particular number, say putting in a 3 here, or putting in a 4 here, instead of putting numbers, let's take the whole function and put it in there. So here's this f of x, this f of x. Instead of putting a number in there, in place of that x, I'm putting this whole function in there. I'm putting it in. Now let's solve and see what we get. I landed back to the x. I got the back set. Everything canceled out. I landed to that x. Now let's take this function and put it inside this one and see if we get that x again. I got the x again. Everything cancels out. This idea I just taught you is called composition of functions. Okay? Putting one function into another function. If you need a recap on that, you can check this video up here. But even if you never watched this video I made, this is what it's saying. You take a function and you put it into another function. If you land back at where you started, those functions are inverses of each other. That's what this is about. Now you know inverse functions. I hope I made sense to you. If I didn't make any sense to you, you can check out my description, all right? I linked other great teachers on YouTube who also taught me. Maybe it's my voice that you don't like, or maybe my face. Perhaps maybe with them you'll understand. But I hope I see you next time, and cheers. Oh, one more thing. This does not equal this, all right? I know you might get confused about that exponents. I know, mathematicians, you guys should have done a better job. But this is not that. It's just notation, all right? It's the language of the inverse. F inverse, it's called F inverse. It's not F to the power -1, okay? If you wanted to write this, if you wanted to express this, you would write it like this. Now this is this. Now this is to the power -1. Don't confuse this with this. It's just notation, okay? And one more thing. This represents the original function, right? This f of x. This represents the inverse of that, all right? Don't get confused with notation. I know the notation can be very confusing. I also got confused once, all right, when I was learning. It's the original function. This represents the original function, but this represents the inverse of that original, all right? So if it was g of x, what would the inverse be? G inverse x. If it was p of x, it would be p inverse x. Do you get it? They're opposite. They undo each other.